Welcome you all back to another episode of ThinkTech Hawaii's Humane Architecture. And we're continuing our search for a more ethereal way of dwelling in dignity on our islands of Hawaii. And we is me, your host, Martin Despang, broadcasting live from near Munich, Germany. And on the other hand, we have Larry Medlin back from the Rapalis studio in Tucson, Arizona. Welcome back, Larry.
It's nice, very nice to be back, Martin.
Good, always good to have you back, Larry. And yeah, on this first slide here, our topic, even though you're talking about something that traces back to the late 60s and early 70s, this just at the top, the USA Today news just shows how couldn't be more current the topic we're talking about, because the Biden-Harris administration infrastructure plan calls for cities to limit single-family zoning and instead build, and what it should say here more specifically is affordable multi-dwelling, multi-story housing. And that gets us back to just quickly recapping, Larry, what we did in the last show. While you had sort of perfectly embodied the tensile membrane system at its very best with the German Pavilion on the Expo 67 in Montreal, while this is certainly a very civic and that way not elitist typology, but you wanted to push it to an even more egalitarian typology of multi-dwelling. And just quickly recap what we've been talking about that in the last show, Larry.
Well, we talked about the SpaceNet project that we did as a two-part process. We built an experimental structure you see in the lower left right now. And then what we're going to talk about more today is the test that a SpaceNet could really be developed as an architectural entity. We took a site in Clayton, Missouri, and which is a suburban center outside from St. Louis. And we accepted a graduate student master's thesis about the planning principles. And then there was a desire in the Clayton government to make a link between the Clayton Governmental Center and a nearby very highly used public park, and to, in that area, to establish a place where people could live and dwell and have multi-use activities, and also have specific private dwellings, but at the same time have large public gathering spaces and activity that could theoretically go on 24 hours a day.
And to illustrate that even more, go to the next slide and let's look at the slide, Larry.
This is a slide. The upper right is the outline of St. Louis. You see the Missouri River going across the top and the Mississippi River going down on the east side. And the main east-west street goes out to where you see an L-shaped gray spot. That's Clayton. That's the silhouette of Clayton, which if you look below, you can see that same shape. And then within that is the model of our specific site in Clayton.
Mm-hmm. And the educators in us, we always tell the emerging generation, if there's one drawing that we prefer over all the others, if we have to choose one, it's the section. So let's look at your creation in this sort of all comprehensive comprised sectional drawing. Next slide, where we see where it all comes together, and walk us through what we see, Larry.
That's the SpaceNet. First of all, one of the main advantages of the SpaceNet is that it floats above the ground. It's free. So that would allow for, as in the case of this specific example, for it to go over existing buildings if it was desirable to keep them, or to build new major public event spaces or activities underneath it. So that's the one real advantage of the SpaceNet. It's independent and floats up above, and also it can be configured so that the edge points and the anchorages are placed where they're discrete in reference to the infrastructure that it's over the top of. And then down below that, you see at the ground level, that's reserved for automobiles with parking and services and so forth for those levels there. And then in between is three levels that sort of interact with public pedestrian space where you can move around and make connections and go up and down. Uh, if you look specifically at the section, right at the bottom, you see where there is a stair coming up and it goes right into a public space. It's put as, for example, to illustrate the potential for a major public assembly or an event center to happen in a spot like that.
Hmm.
The other thing that we're going to look at in the later slides, when we look at this, you see in this sort of the basic SpaceNet cross section, the narrow part up at the top is resolved for one single loaded corridor for apartments, and then where it gets wider down below, it has a central loaded corridor for office spaces. Well, in one of the slides we're going to see later is that if you didn't do the office spaces, if you continued the dwelling units right down the right side of that, so you'd get come over and then you put an axis between it and flipped it over, you'd end up with an open space in between it, as we're going to see in a next slide.
Yeah, and as my professor Schwager back in school, me as a student always said, that model I don't trust, I don't believe. Here it's almost reversed that this drawing here, the structure just looks like almost unbelievable. So you once again tested that in your methodology of model making, and let's look at that on the next slide.
This is a basic sort of test block for a space net. So what you see is the principles, it's held up by a synclastic surface, a two-directional curvature of the same sign, that lifts it up and supports the hanger cables and pre-tensions the system. And then it has just the inverse down below. It has a restraining net of cables that draws it down. And then they go out to major ridge cables and tie down cables and so forth that go away from that. See, the critical thing is that's a space net block, but it's got to be laterally stabilized. So that can be done by, as you see, is the suggestion in this of a couple of guys going out to the right at the top and left at the top, or it could be tied into another space net element to keep it as a part of a system.
Hmm. And since we're also our Primitiva 3 team that we're coaching for Tensile Tower in Hawaii is currently in the final sprint of the semester. And we'll reach out to you, by the way, as far as your model expertise. Here again, you said, and sometimes, you can use rods or little wires, right? And solder them together rather
That's
than.
exactly the way this thing was made, which
Mhm.
means that you start out very systematically. You start out in the middle, and then you go and you progress out, and if you make a mistake, you can come back and touch it with a solder and loosen it and adapt to them. It's an error. So that way you get the important point is that the perimeter cable, or in this case, the what if it were a bridge would be the suspension cable, is to be a smooth, continuous curve.
Mhm. And as we've been talking a lot, this way, very sort of tensegrity way of thinking and building is more than any other topology always about zooming in and out. So while soldering the little connection points, your mind was zooming in how that would come together in reality. And as you mostly then have tested that through real scale prototyping, and here you also did through drawing the details. And let's look at that in the next slide.
This is the basic, the slide on the upper left is the basic joint. You see the big cable coming down is the main hanger cable. And then there's cables going to the lower left-hand corner and to the upper right. Those are the lateral cables that pre-stress the system and keep the vertical hanger cables in the correct position in the space net. But then the front to back element is actually a beam. And the reason for that beam is it spans front to back, and that allows you to slide the capsules, the modular elements that we talked about in one of the last shows of how you assemble them in different combinations of a full module, a half module, an outdoor wall, and a patio module. to make a whole variety of things in terms of what you wanted to achieve in terms of the plans and the objectives for the various residential sizes and so forth.
Yeah.
That,
And
that
yeah, go ahead.
I was going to say, and then on the bottom, that is a diagrammatic sort of sketch of what the details would be for one of the tops of the main mast. You see where there's a bundle of 9 cables there in the middle. That's what would be the sling cable, or the running all the way at the longitudinal distance, and then the ridge cables that go out to the outside are shown on the left and right there to stabilize that. And you can sort of see that from another view direction right next to it. And then you can see on the right a diagram of how a space net could be tied into another space net and take the loads, or eventually it's the loads have to be tied down into the earth and anchored it in some way. Not necessarily the earth, maybe the infrastructure below could be shaped and formed to be strong enough to be an appropriate restraining cable.
Hmm. And methodologically, while you're on this sort of how, so like the structural engineering of it, at the same time, you've always been thinking about the why, which is the social engineering. And that gets us to the next slide, Larry.
Well, this is what I was talking about earlier. This is, if you look, uh, and the photograph on the left is one end of the space net. It's the space net that literally moves out to the left to the park that's next to it, and then it goes down to the front of the picture or the south to make a connection with the governmental center. But you see, if you look at the doubled space net where it's opened up on the upper right of that image, if you look carefully, you can see there's an opening in there, and that's what I said. In this case, it would have residences running down all the way on both sides, all the way to the ground without any office space. But that would reveal this common public activity and social space with common use activities, as you see in the sketch on the right.
Yeah. And the model picture also perfectly portrays what the Biden and Harris administration is currently talking about, that we can't continue to do that sort of sprawling of single story that we see in here in the neighborhood, right? So you're kind of rediscovering what you were on already here some many decades ago already, basically to densify, right? While yet bringing the kind of the challenges, and the task is to provide what people love in their single family paradise, to bring into the third dimension, right? And we're going to have a little reference picture, because we're going to show later. It somehow reminds us also of the kind of housing that went with Frei Otto's a few years later, 72 Olympics here, which was done by Hein Lewischer and partner. There's a lot of similarity of thinking, and actually also of execution, at least on the sort of the conceptual level. However, in the making, in the materialization, it's the extreme opposite, and we will talk about that later. So let's go to the next slide, or did you want to stay on that one for a little
No,
longer?
this is just another view of it, showing that sort of how it opens up to a public spaces. Even suggested the possibility of a little monorail could come through, or a suspended tram to provide connections to local transportation. And also, if you look at the photograph on the right, you'll see how there's actually the structure makes a bridge over a major north-south street in St. Louis County in Clayton. So it connects that together. The blocking that you see on the right is the part that coming towards us on the right is the connection to the governmental center. And then as you go across, it opens over, and outside the left side of the left side is where it edges right on the park.
Yeah, and as you mentioned it, we all know that the second largest other focus of the current Biden-Harris administration is infrastructure, and especially public infrastructure, right? And basically fostering public transportation. So you foresaw all that in a pioneering way. And let's go to the next slide that shows us that model as a whole.
Well, that's just an overall view of the whole. You see sort of the existing buildings and so forth there. And then this is actually looking from the park side as it moves around and comes down and suggests how that would be tied together.
Beautiful model. Again, this is cheerleading our team that will be soon in the model making for the Hawaii Tower that we're going to talk a little bit towards the very end of our sequence of shows here.
Well,
Let's go to the next slide. And basically, once again, this is the compendium of the entire brochure that you've been sharing with us today and in the last show. And if you're ever going to be in Tucson, Arizona, let Larry know, and he can, sit down with you and flip through the brochure. And these are pictures you took, and I think the background of what the brochure is laying on, somehow we've seen before, right?
that's the marble slab that was a measuring table that we talked about in one of the last shows. I still have that, still use it. Currently, it's used as my office desk and or dining room or whatever is appropriate at the moment. So,
Mm-hmm.
let me just make a few comments about the future of space nets. This was, we tried to do this hypothetical model, and we wanted to show that we could satisfy all the public safety codes for access and potential to fireproof the members and all that sort of thing. But an important thing is that when you get to this size and scale of a structure, it becomes very important to do analysis where you optimize the overall configuration of the system. And that wasn't done at that time. And in fact, the technologies for analysis now would help that sort of thing to happen. But to sort of illustrate that point, if you just take a catenary line and if you put it horizontally, it has to have infinite tension to hold any weight. And if you hold it straight up and down, it holds its own weight. So theoretically, somewhere around a slope to span of 1 to 3 is sort of ideal for most efficient use of a catenary member. But if you did that, and that would mean that the towers would have to be that support it would be huge. And so in reality, almost every major suspension bridge of that type in the world has evolved to a system where the towers are lower, so the span to sag ratio is 1 to 10. And the point is that that's through the thorough interactive system element of maximizing the most efficient use of all the materials as a composite system. And that kind of analysis would be obviously desirable as an interactive point in the design and development of any future space nets, and even more critical than just something like a suspension bridge to really optimizing the configuration. And the point being that if you have excess material in something this large and this complex, it just it goes the opposite direction for what you're saying, providing affordable housing.
Yeah, and it's fascinating, when you're talking to put this into the context of time, the zeitgeist of the 60s, while the movement of metabolist people, they had their kind of futuristic and fantastic kind of visions first, and then it enlarged. It didn't really materialize architecturally in real projects, and in some cases it did, but it was often it was kind of losing its kind of power. Well, here it's really the opposite, because you're coming from having prototyped this technologically just before that. And let's go to the next slide. And we've been talking about that in many of the previous episodes here, but this is something again which you're calling your summer of 66, and this is something you pointed out to me that's out there on the web, and you wanted us to share that with the audience. So what is this referring to?
Well, those are images from the installation of the German Pavilion on site in Montreal during the summer of 1966. You see on the lower left is the cable net was up and preliminary stretched, and you can see people can walk around on it and stand on it, and then the fabric roof is suspended down below that. The upper one is the grid shell that was prefabricated, ironically, in Germany and shipped over to Montreal, and that you see that's in the process of going up. And then the lower right shows the process of how the masts were set up on a steel plate, a rubber membrane, thick rubber piece, and then another piece of steel on a pot full of sand. So you jack it up and then put sand and let it compress it back. It was a standard bridge building technique adapted so that by the combination of pulling the guys around the perimeter and jacking up the mast and reading the strain on the mast and the tensile points around the perimeter, you could determine exactly how the stress was coming in and if it was correct and if it was too much in one direction or the other and adjust it. So you had literally a balanced sort of installation of the structure.
Yeah. And when you pointed out this video to us here, which is on Arc Daily, and then also our interactions made us basically having you reconnect to your comrade Jürgen Hennecke. And then when I was talking,
he made this video. He put all
exactly,
the bits and pieces
exactly,
stuff together.
exactly.
Yeah, he did a
And so,
fantastic job on this.
and there's a couple other ones you and he said, right?
Well, there's one on soap films that Frei Otto was talking about, and there's another one on various forms. There's 3 or 4 out there on the
Yeah,
web.
yeah. And he said there's one about Munich Olympics 72 as well.
Right. You know, Frei Otto got the Pritzker Prize in 2015, and there's several comments and reference to articles there, and there's some linkages to all of these things in some of those sites as well.
Yeah, yeah. And that's true. And we further want to have the audience remember sort of where were you guys when you were around already at that time. So talking about the summer of 66 and how that sort of spirit was really becoming very characteristic for the late 60s and early 70s. And that gets us to the next slide. Because this is to the left is me screenshotting when we were having sort of like a lazy Sunday afternoon and we're testing and coming up with the idea for doing the shows, and we're resuming the first time. And we see us very casually and we see you up there in your house, which is also sort of demonstrating many of the principles and actually more because, you know, as your friend and colleague Frei, you guys were interested in the free, that both structurally and architecturally, but also in terms of bioclimatically, right? How to live in balance with the nature. And you're demonstrating that in a total piece of artwork, basically Gesamtkunstwerkmäßig in your own life. So tell us a little bit what your house looks like, what we're
Well,
seeing.
it was built out of Tucson brick, which is a slightly larger than the standard brick, and a double layer with an airspace in between. So it has a very good thermal time lag, sort of like adobe. And this was on the second floor on the north side, where there's 3 windows down one side and a big window on the east side. So I like the fact that I get morning sunlight coming in on the east side to tell you the day is starting. And then above, I put in a Velux skylight that can also be open to have an outdoor vent. And then there's another skylight. And I have an indoor-outdoor thermometer. So when I see that it's cooler outside, when the temperature drops in Tucson, I turn off any kind of cooling system and just open up the windows and let it vent through. And that seems to work really nicely. So basically, it's taking what was a very well built for its time building envelope at the time, and just taking advantage of the fact that it's on the second floor, so it's above the tree line. So there's always a good sustainable breeze going across that from one direction or the other. And by opening and closing the appropriate windows, you can always, you know, get a nice draft or control it if you don't want it.
You know, and for me, the summer of 66 was a special one because I saw the light of the earth in this year. And later in the 80s, this is the row of pictures on the right. My father bought this row townhouse here and basically did the same to it, what you're explaining to us. He was opening up to the south, providing large outdoor lanais and, sunshine and shading and just cross ventilation. So it was really kind of that zeitgeist, right? That we were all, I mean, we were all living at that same time. And so that gets us to the next slide, because that gets us back to Frei, because Frei had these two sort of, well, they weren't two sides, they were one. But since you guys started out so fantastically with these very, most amazing typologies of a World Fair Pavilion and Olympic Stadium, at the same time, Frei really wanted to also demonstrate and prove the sort of inhabitable freedom, Freiheit, living in balance with mankind and nature. And this is a compilation of demonstrations of that. And walk us quickly through, Larry.
The lower one on the lower right is his house in Warm Run. We may have seen some photos on the inside of that. And if you look at that, it's got a big greenhouse space in the middle that's open, and it has a rolling shade that can provide shade underneath that or open it. And then it has a big garage door size door of glass on the south, so you can open it and bring a window into there. And there's a spa area right behind that. And then the bedrooms and living spaces sort of wrap around that. So one of the wings of the building actually goes through on the upper level in the north. And we're looking at it in this case from the eastern side. So by opening that up, you can do the same thing, ventilate it cross direction, and also then capture sun in the greenhouse space, and then vent that into the dwelling spaces and sleeping spaces at night.
Yeah. And the one to the left is demonstrating that in a fantastic project in the Tiergarten in Berlin, with sort of a co-op housing project he did. And that's also the two top pictures on the right, which is showing interestingly sort of like that he was similarly what he was doing otherwise with what you just showed in the St. Louis project, that you built a framework and then the infill could be more almost like done sweat equity wise by the people. And that's what's been doing here. There's just the raw framework construction in concrete, and then the infill is the more homey kind of self-made kind of wood construction.
Herman Kendall was a principal working with him, and he was on site and followed us through all the way in Berlin. And there were guidelines as to how you would develop those dwellings, and people would simply come to, they had a design review committee, and when you proposed what you wanted to do, they'd give you comments. So each person was allowed to sort of create the kind of space and the ratio of glass and openings and stuff, but it had to be somewhat compatible with the existing area. And the important thing was it was raised up, so there was boardwalks. Nobody walked actually on the ground surface, so the surface water and all the nutrients and things that were there were preserved and allowed to flow through the site. And this was, as I mentioned, done by Herman Kendall, and it was a sort of an interactive process with, I think it's about 20 or 25 dwellings in this, and each homeowner met to sort of discuss how, what it should be and how they could relate to each other. At first, people thought it was just some sort of, literally, they were saying things like a hippie freak show, but now it's some of the most popular residential areas in Berlin.
What a compliment. And that gets us to, believe it or not, the end of another exciting 28 minutes. And we're going to continue next week. And until then, stay all safe and sound and increasingly easy breezy as Larry and Frei. Thank you, Larry.
Thanks, Martin. Bis nächste Mal.
Bis nächste Woche.